lesson 7.3, we get to introduce something, I get to introduce something called logarithms. And to my knowledge, logarithms were not an Algebra 1 topic. I don't think you've ever dealt with logarithms. Correct me if I'm misspeaking here, but so this is a brand new topic. Now, logarithms come up in this chapter because they are the inverses of the exponent function. And what have we been working with? We've been working with exponents, haven't we? When we were just graphing, we were graphing things like y equals 2 to the x, y equals 3 to the x. And so the connection here is that the logarithm function is the inverse of the exponent function. Now, there is a log button on your calculator, and we will use it some. There will also be some things, though, that the log button does not take care of for us. So, logarithms. Log base b of x equals y. So notice that little b is subscript b. You know what I mean when I say subscript, right? So log base b of x is equal to y is the logarithm equivalent of b to the y equals x. And that whole idea of b to the y equals x, that's what we've been working with. The exponent equation where your number is a base and you've got your exponent is a variable. Now, so I already read this. Logarithms like the one above are read log base b of x equals y. So log base b of x equals y. So that's one piece of information here. Logarithms and exponential functions can be switched back and forth. And you'll hear me use the phrase left, right, middle. In fact, you go to one of my pre-calc students or calc students and say left, right, middle, they're going to know exactly what you're talking about. Or even go to a student that was in Algebra 2 last year that's not in math this year. It's going to at least sound familiar to them. Okay, so left, right, middle. And left, right, middle, I don't know that there's any official basis behind it. It's just kind of our shortcut of how we switch back and forth from a log function to an exponent function. Because there's times that we can't really do anything with the log function. We need it in an exponent form. And as I mentioned earlier, the log function and the exponent function are inverses of each other. And remember, inverses are where x and y switch. Now, for example, log base 2 of 8 equals 3. When we talk about log base 2 of 8 equals 3, first of all, I'll tell you right now, if you punch in log of 8 on your calculator, it's not going to equal 3. Because your calculator only works in log base 10. Okay? So, this is part of the reason we have to have these other ways, because our calculator doesn't just, we don't get to pick the base. It's log base 10. But log base 2 of 8 equals 3 corresponds 2 to the third equals 8. And so the idea when we think left, right, middle, as you look at log base 2 of 8 equals 3, 2 is the first number you come to, correct? So 2 is my left number. 3 is the last number I come to. So 3 is on the right. Okay? And I'm labeling the pieces, and then I'll show you how it works. And that means 8, of course, is in the middle. So it is the middle number. So the base of your log is the left piece. The inside of the log, and so when I talk about the inside of the log, the main number in the log, 8 is your middle, and then what it's equal is the right piece. And the idea when we use left, right, middle says the left number raised to the right number is equal to the middle number. Did you see that? Left number being 2, raised to the right, equals the middle number. Does that equal the statement down here? Left is 2, raised to the right is 3, and it equals the middle. That connection will always exist. And so that's why we're going to use the phrase left, right, middle. And I think when we have to use it, is it down here, or maybe it's down that section? It'll make a little bit more sense. But just kind of keep that phrase in mind. And one other piece to important information here, the inside parts of a log can never be negative. If you tried to do, I know some of you have played with the log button on your calculator. If you try and do log of a negative number, I'm assuming your calculator gives you an error. I'm not exactly sure what it says, but it's going to give you some kind of error. Because you can't take the log of a negative number. Okay? Is it saying some kind of error? Domain error?
Yeah.
As in, the x value you've put in is not within the domain of a log function. Okay? So, what's it saying? No real answers on that one? Okay. Okay. So, just good information to know. Now, common logs. This is what your calculator does. Your calculator does common logs. Common logs are logarithms like those above, but they always have a base value of 10. So, calculator works base 10. It does common logs. The key is when it is common log, so when it's base 10, you can leave that 10 off. So if you ever see a log and there's no base, we get to assume that it is 10. So instead of having like the invisible 1 like we normally do for an exponent or number in front of x, we get an invisible 10. So we do not have to write the 10. Instead, something like log base 10 of a 100 is the same as saying log of 100. If the base is anything but 10, yes, you have to write that 10. But if the base is 10, you get to leave it off. So that's just good information to know. Now, shall we look at example 1? Example 1, they're giving us an exponent equation. Okay, they're giving us an exponent equation. And they're asking us to write the logarithmic form. So it's the idea of using left, right, middle, but we kind of get to go backwards. So the idea that 2 to the third equals 8 up here is equivalent to log base 2 of 8 equals 3 is the idea we're going back and forth. Okay, the fact that these two right here are equal. Okay, those two are equal there. That's what we're trying to do. Is we're just trying to write the logarithmic form. So, with that in mind, 10 squared equals 100. It's your statement, right? 10 squared does equal 100. We want the logarithmic form. So I want to write log base some number of some number equals some number. I said some number 3 different times, didn't I? Mm-hmm. Notice how many numbers are in this equation? 3 numbers. Thoughts on how we fill this in? Log base something of something equals something else. I need to come up with different words there, but thoughts there? Trevor?
Maybe, well, so for here you don't have to put the little 10, do you?
I'll write it the first time through.
Alright, so you have the log, the little 10, 100 equals.
Okay, I agree. So one way to write this, log base 10 of 100 equals 2. Now, notice Trevor did question, we don't have to write the little 10. Do we have to write that little 10? No, that's the one base you don't have to write. So the other way, perfectly acceptable way to write this, which is what Trevor started to tell me. Okay. My board just did something funky there, and I got a funky 2 out of that. Is log of 100 equals 2. My fear was, though, if I just jumped to that, I'd have people saying, wait, you didn't use the 10. Which is why I did not just jump to that. Now, does this make sense? Okay. If we try, left, right, middle works when you're in log form. So if I try and make that connection, the 10 is on the left. So the left raised to the 2. So left raised to the right equals the middle. And that was the statement made right here, wasn't it? So yes, log base 10 of 100 equals 2. Or log of 100 equals 2. I'm fine with either of those. I don't know, Math Excel might get mad if you put the 10 in there. You know how Math Excel is, it's 50-50 there. Things to look for. The base of my exponent here was 10, yes? The base of my log is also 10. So that's one good connection to make there. And I know then some people will say, oh, well, then my 2 and 100 just flip. Again, as long as you can make it make sense for your brain, that's what matters. Try B. What's B say? 1 equals 3 to the 0. I'm curious, did I rewrite these? Are you guys okay with the order this is written in? Some of you don't care. It's gross? Okay. If it's gross to you, what should you do? Can you flip this? Three to the 0 equals 1. If that works better for your brain, then by all means, do that. If that was an unnecessary step for you, that's fine as well. Okay, guys. Log base what of what number equals what number? There's my help. The word log. Big help, I know. Thoughts here?
Would be 3.
As in log base 3? Yep. Log base 3 of 1 equals 0. You guys got it? Okay. So that base of 3 is the base of log. Log base 3 of 1 equals 0. You got a way for it to work for you? Because it really is just come down to remembering it. Okay, C. 81 equals 3 to the 4th. Again, if you're not comfortable with the way it is, then by all means, flip it and make it 3 to the 4th equals 81. Okay, what do we got here? Hope I forgot to give you my help. Log. Okay, log base 3 again, because that 3 is the base up there. Of 81 equals 4. Notice I'm not giving you an either or option on these last two, am I? They're not base 10, so we have to write the base. D. What are your thoughts on D? There's fractions, which makes you think, yuck, but does it matter for this? No. All you're doing is writing the pieces. Can you have fractions within logs as base of logs, equal to logs? Yes, you can. So, log base what? What you got, Justin?
Log base 2/3 of 8 over 27 equals 3.
Okay. No one said it was going to be pretty to look at. So log base 2/3, that's the base of the power up there. Log base 2/3 of 8/27 equals the exponent of 3. Technically, that 8/27 might need to be in parentheses. I'm not sure. I honestly don't have it in parentheses here. Again, fractions can be gross. Doesn't necessarily mean it has to be gross. Okay, questions on that section? Easy enough? Okay, moving along. Example 2. The question is, what is the value of each log? So I want to know, what does log base 8 of 32 equal? Can I plug this in on my calculator? No? Why not?
Because we don't have a base of 8, we have 10.
Yeah. You guys don't have a base 8 button, do you? that log button on your calculator is just going to give you log base 10. Okay, so we need a plan B, don't we? Because the calculator's not going to help us out here. My suggestion, we're trying to find what this log equals, correct? So my suggestion is that I make my log equal x. So now I'm trying to find x. Can you take this out of log form and put it into exponent form? What's the phrase I mentioned earlier? Left, right, middle? That's exactly what we're doing here, folks. Because we're going to do a left, right, middle. Or for the record, if you ever see me write LRM, when I write LRM, that's my shorthand way of saying, hey, you should think left, right, middle on this. Okay? So, log base 8 of 32 equals x. Rewrite that using left, right, middle. What's my left number? The base 8 raised to the right. What's the value on the right? X equals the middle. What's the number in the middle? 32. So now, 8 to the x equals 32 is the equation we have to solve. Helps a little bit. Thoughts? Do you know 8 to some power that equals 32? No. 8 to the first is 8. 8 to the second is 64. My question to you, can you come up with 8, can you rewrite 8 and 32 using exponents, but using the same base? Can you rewrite 8 and 32 with exponents? So something to some power equals 8, and something to some power equals 32. Any thoughts on numbers that work there? I know I see various people playing on calculators, either trying to find answers or trying to... Last chapter you had a blue paper, yes? I'm going to share a yellow paper with you this time. Gold, what color? Goldenrod. I don't know, what color do you want me to call it? So take one and pass them back, if you will. And then we will talk about how I feel this paper can help you. Because I think once you look at this paper and start seeing it, it will make sense. Some of you won't leave the paper, you know, kind of like the blue paper. Some of you, yeah. I think, yeah. I had some, one year I went to color, because like I copied some new ones this year, they're probably the bottom pile. And I went to copy and like they didn't have the right color, so I had to. Okay, you have this paper in front of you now, yes? Okay, so I asked you to look and see how can I rewrite 8 and 32 using the same base. So if you looked at this gold paper, it's kind of like your square root paper, isn't it? Except instead of square roots, I did powers. So 8 and 32. Do you see 8 and 32 on here anywhere? Do you see 8 and 32 in the same column?
Yes.
Where do we see 8 and 32? They're both in the 2s? And this will maybe make sense if you think about it. What is 8? 8 is 2 to the 3rd. So let me rewrite this. 8 is 2 to the third. And then, of course, that's going to be raised to the x. What is 32? 32 is 2 to the fifth. What did I do? I just rewrote these both with the base of 2. And that's going to be our goal here, okay? Is how can you rewrite these bases with the same base? So in this case, it was how can I make 8 and 32 have the same base? Now, first of all, 2 to the third raised to the x. Do you remember how to raise a power to a power? In order to raise a power to a power, we just multiply. And 3 times x is 3x. So the equation I now have is 2 to the 3x equals 2 to the fifth. Think logically. If the bases are the same, right, this is an equation, right? Both sides are equal. If the bases are the same, what's going to have to be true about the exponents? The exponents are going to have to be the same, right? Somehow, 2 to the 3x has to equal 2 to the fifth. So, the nice part is here, once you get the bases the same, we can drop the bases off and just solve the exponents. So since it's 2 to the 3x equals 2 to the fifth, I can drop the 2's off, and the equation I have is 3x equals 5. How do you solve 3x equals 5? If it's 3 times x, we're going to divide by 3, and x is 5/3. So Noah, did you find that answer when you were over there playing?
1.6 repeated.
Okay.
It's 16 sixes and 5.
Is that what yours came up?
Yes.
Basically, it's the same. Yeah. Okay. So if you sat over there playing with it for a while, which I know a couple of you did, I said no because I knew I could see he was over there playing like a calculator. I knew that's exactly what he was doing. It is possible to find it eventually playing on the calculator. However, I'm going to encourage you to, once you know how to set up the equation, it's going to be quicker and easier. That's going to be my suggestion. Okay? And obviously, 5/3, it's not quite as easy. So, okay, questions on that? Shall we try B? Log base 5 of 125. Can I plug it into the calculator? Nope. So for the visual effect, I'm going to say it equals x. What's the equation I rewrite this as? Five to the x equals 125. Left, right, middle. The 5 on the left raised to the x on the right equals the middle value. What are you doing now? Just randomly plugging in numbers so you find the one that works? This time it would be a lot easier to do that, wouldn't it?
Yeah.
Okay, that's an option. What am I going to suggest? I'm going to suggest look at the paper, and where is 125 on this paper? It's in the 5 column, isn't it? 125 is 5 to the third. So if I say 5 to the x equals 5 to the third. Did I get my bases matching? Yeah, I got my bases matching, didn't I? 5 to some power has to equal 5 to the third. What's the only logical number to go in place of x? 3, right? If 5 to some power has to equal 5 to the third, well, it's got to be 5 to the third. So again, if the bases are the same, drop the bases and set the exponents equal to each other. So x equals 3. Okay. Do you know what to do on C then? log base 4 of 32. I don't know if you need the visual or not, but I'm going to say equals x. What's that equation I'm writing?
4.
Okay, left, right, middle. Base of 4 raised to the x on the right equals the 32 in the middle. Okay. If you want to just start playing on your calculator, 4 to some power equals 32, more power to you. It's doable. However, not my encouragement. Did your gold paper help you, honey?
Yeah.
What am I looking for? I'm looking for
32 and 4.
32 and 4, preferably in the same column, yes. Where'd you find them?
First column.
In the 2 column? So let's rewrite it. 4 is the same as saying 2 to the second. Now officially it's 2 to the second, raise the x. 32 2 to the 5th. So officially this 2 raised to the second, raise the x, 2 times x, so it's 2 to the 2x equals 2 to the 5th. If my bases are the same, what do I get to do? Math. We're going to drop the bases and set exponents equal to each other. 2x equals 5. If 2x equals 5, divide by 2, and x is 5 over 2. Okay. Not half bad. Ready for the next one? No, not exactly. Okay, there's fractions. Are we going to see fractions? Yeah. And yeah, we do have to work with them, so let's follow the same process. I'm going to take log base 64 of 1/32 and set it equal to x, correct? What's my statement I'm going to write?
64 x equals 1/32.
Okay, left, right, middle. So the 64 on the left raised to the x on the right equals the 1/32 in the middle. Now, here's my recommendation. Don't stress about the fraction for the moment. Just leave it in there. It's fine. What numbers do you see that we want to have the same base? 64 and 32. Well, we've only used 32 2 other times today. Do you know that one yet?
Yeah.
It's 2 to the 5th. What do you know about 64?
2 to the 6.
It's 2 to the 6th, right? Take 32 and multiply it by 2. So let's rewrite this. 64 to the x is 2 to the 6. So I'm going to rewrite this as 2 to the 6 raised to the x. 1 over 32 is going to be 1 over 2 to the 5th. Bases are almost the same. I mean, we have the 2's, yes. The problem is I have this fraction. And I just need, instead of it being 1 over 2 to some power, I just need it to be 2 to some power. How do I get 2 to the 5th out of the denominator? No? What allows it to just move to the top? A what? A negative exponent? What if 1 over 2 to the 5th, is that equivalent to 2 to the negative 5th? Because think, we've been working with negative exponents this year, right? 2 to the negative 5th, if that's a negative exponent, what would you normally do to get rid of the negative exponent? You move it to the denominator. So since it's in the denominator, how do I get out of the denominator? Put that negative exponent. And I'm okay with a negative exponent right here. So I end up with 2 to the 6x equals 2 to the negative 5th. If the bases are the same,
Now you can.
now we can drop off the bases, right? My 2's match. So we can set our exponents equal to each other. 6x equals negative 5. Divide by 6. And x equals negative 5/6. Okay, you're getting better at this, right? Hopefully the gold paper is helpful. And I think once you see how this works, you'll know some of these powers, and some of you won't need the gold paper as much, but just in case, it's still there. Okay, what about log of, what is that, 1,000? Well, like the others, I'm going to set it equal to x. What happens when I do left, right, middle? Okay. My left is, what is the base here? Invisible base is 10. Okay, you just got to know that. There's no base written in. It's the word log. It's base 10. So I can rewrite this as 10 to the x equals 1,000. Now, you're not going to find 1,000 on that gold paper. Okay? But this is where we have to kind of think about what we know. And I think it will make sense to you. But what do you know about 1,000? It's a 1 with 3 zeros. What is that? 10 to the third, right? Because 10 times 10 is 100. Times another 10 is 1,000. When you have a 1 with zeros, the shortcut is that a 1 with zeros is 10 to however many zeros there are, that's the power it is. So 1,000 is 10 to the third. So now I have 10 to the x equals 10 to the third. Well, the bases are the same, so x equals 3. So no, I did not put a list of 10s on here. Could you put a list of 10s on here if you want, I guess?
Absolutely.
Sure. 10 to the second is 100. 10 to the third is 1,000. 10 to the fourth is 10,000. 10 to the fifth is 100,000. You could. Now, did anyone do this one a different way?
I just use a calculator.
Oh, did you just put it in the calculator?
Well, I kind of do.
Okay.
I put my calculator.
So, on this one, could you have just put it in the calculator?
Yes.
Yes, because it is log base 10. This is the first problem today that you put it in the calculator, our answers are going to match, right? All these others, A, B, C, D, you put them in the calculator and you don't get a matching answer because they were not base 10. This one's base 10, you put it in the calculator, yes, it matches. Okay? And it's not cheating, you can use the calculator here. Because here's the deal, are you going to see me put a bunch of base 10s on the homework or a quiz or a test or anything? No, I'm going to have the other ones on there that you can't just plug in the calculator. So, do practice using the log button. We will need it at times in this chapter. Where am I at on time? 10:58. Okay, let's go ahead and look at example 3. It's words, so I know you're stressing and it looks difficult, but it's not. In December 2004, an earthquake with a magnitude of 9.3 on the Richter scale hit off the northwest coast of Sumatra. In March 2005, another earthquake with a magnitude of 8.7 hit Sumatra again. The formula. Oh, I love that when they say that. They're giving me the formula, yes? The formula. Log of I1 over I2 equals M1 minus M2.
What?
Compares the intensity levels of earthquakes, where I is the intensity level and M is the magnitude. How much more intense was the first earthquake compared to the second? And notice what it says there. The quotient, I1 over I2, compares the intensity. So, we have a formula, yes? Makes life so much easier. So we're going to be filling in that formula of log of I1 over I2 equaling to M1 minus M2. I is intensity, M is magnitude. What did they give us here? They gave us numbers. What kind of numbers? 9.3 and 8.7, and those were the magnitudes. So for M1, I'm going to fill in the first magnitude of 9.3. For M2, I'm going to fill in the second magnitude of 8.7. My left is just staying the same for the moment. Log of I1 over I2 is equal to 9.3 minus 8.7. What is 9.3 minus 8.7? 0.6. So again, the log of I1, intensity 1 divided by the log of intensity 2 is equal to 0.6. I need to solve for those i's. How do I get this out of log form? Put in exponential form, right? What's my little word phrase I'm using? Left, right, middle. What is my left? Invisible base 10. My left is invisible base 10. So when I rewrite this, left is 10. 10 raised to the power of, what's on the right? We have 0.6 this time, is equal to the middle. What's in the middle? Intensity 1 divided by intensity 2. What's the calculator answer for 10 to the 0.6? Shouldn't be negative. 10 to the 0.6. 3.9 something?
Yeah.
3.99 something? Okay, 3.98, which is approximately what?
4.
Approximately 4. So, how much more intense was the first earthquake to the second earthquake? Approximately 4 times as strong. So your answer is that 4. We don't have to find I1 or I2. It is the fact that that ratio equals 4, so it's approximately 4 times as strong. Okay, tomorrow we will pick back up in the notes. Math Excel should be available. You can get started on it. It will not be due till Wednesday. And don't forget your phones. If you're going to make any more test corrections, make sure you check in with me. Come see me at some point.